Welcome back to Algebra with Miss Swartz. Today we're looking at radicals and rational exponents. So we've talked about exponents a lot. We've worked with radicals in the past a little bit, specifically with the Pythagorean theorem and the distance formula. But we're going to actually look at both of them today. And then when we talk about rational, we're going to be looking at exponents that are fractions, which goes along with the radical piece. So to start, I want to give you an intro of rational exponents. And to do that, I think Mr. Khan does a really good job. So what I'm going to do is I'm going to enlarge this and I'm going to play it for you. You can listen to him talk about exponents. He does a good job of kind of breaking some things down. I might not play his whole video, but play a lot of it. So I got to turn him up here a little.
The number 4 and raised to the third power. This is equivalent to taking 3 4s and multiplying them. Or you could also view it as starting with a 1 and then multiplying the 1 by 4, or multiplying that by 4 3 times. But either way, this is going to result in 4 times 4 is 16, times 4 is 64. We also know a little bit about negative exponents. So for example, if I were to take 4 to the negative 3 power, we know this negative tells us to take the reciprocal 1 over 4 to the third. And we already know 4 to the third is 64, so this is going to be 1/64. Now let's think about fractional exponents. So we're going to think about what is 4 to the 1/2 power. And I encourage you to pause the video and at least take a guess about what you think this is. So the mathematical convention here, the mathematical definition that most people use, or that frankly all people use here, is that 4 to the 1/2 power is the exact same thing as the square root of 4. And we'll talk in the future about why this is, and the reason why this is defined this way is it has all sorts of neat and elegant properties when you start manipulating the actual exponents. But what does the square root of 4, especially the principal root, mean? Well, that means, what is a number that if I were to multiply by itself, or if I were to have two of those numbers and I were to multiply them times each other, that same number, I'm going to get 4. Well, what times itself is equal to 4? Well, that's, of course, equal to 2. And just to get a sense of why this starts to work out, well, remember, we could have also written that 4 is equal to 2 squared. So you're starting to see something interesting. 4 to the 1/2 is equal to 2. 2 squared is equal to 4. So let's get a couple more examples of this, just so you make sure you get what's going on. And I encourage you to pause it as much as necessary and try to figure it out yourself. So based on what I just told you, what do you think 9 to the 1/2 power is going to be? Well, that's just the square root of 9, the principal root of 9. That's just going to be equal to 3. And likewise, we could have also said that 3 squared is, or let me write it this way, that 9 is equal to 3 squared. These are both true statements. Let's do one more like this. What is 25 to the 1/2 going to be? Well, this is just going to be 5. 5 times 5 is 25. Or you can say 25 is equal to 5 squared. Now, let's think about what happens when we take something to the 1/3 power. So let's imagine taking 8 to the 1/3 power. So the definition here is that taking something to the 1/3 power is the same thing as taking the cube root of that number. And the cube root is saying, well, what number, if I had 3 of that number and I multiply them, then I'm going to get 8. So something times something times something is 8. Well, we already know that 8 is equal to 2 to the 3rd power. So the cube root of 8, or 8 to the 1/3, is just going to be equal to 2. This says, hey, give me the number that if I say that number times that number times that number, I'm going to get 8. Well, that number is 2, because 2 to the 3rd power is 8. Do a few more examples of that. What is 64 to the 1/3 power? Well, we already know that 4 times 4 times 4 is 64. So this is going to be 4. And we already wrote over here that 64 is the same thing as 4 to the 3rd. I think you're starting to see a little bit of a pattern here, a little bit of symmetry here. And we can extend this idea to arbitrary rational exponents. So what's happening what happens if I were to raise, let's say I had, let me think of a good number here. So let's say I have 32. I have the number 32, and I raise it to the 1/5 power. So this says, hey, give me the number that if I were to multiply that number, or I would have repeatedly multiply that number 5 times, what is that? I would get 32. Well, 32 is the same thing as 2 times 2 times 2 times 2 times 2. So 2 is that number that if I were to multiply it 5 times, then I'm going to get 32. So this right over here is 2. Or another way of saying this kind of same statement about the world is that 32 is equal to 2 to the 5th power.
Okay, so that gives us a good start. So to go along with that, something else we need to understand. So he did a bunch of examples where he had, okay, just 1/2, 1/3, 1/5 he did an example of, and he showed you, okay, it's the same thing as the square root of 4. Okay, well, this same idea can work with any fraction if we understand the difference between radical form and rational form. Okay, so here's our rational form with the fraction, and the radical form is here with the radical. So what we're going to look at is now we want to be able to write both types with any fraction, with any exponent, any situation. So you have to understand, let's give you an example here. Let's say x to the 2/5 power. If I want to write that as in radical form, okay, if I look at everything that he showed me in my examples, I had 1 in my numerator. Essentially what I'm doing is I'm raising 4 to the 1st power and then finding the square root of that, or the second root of 4. Okay, well in this case, now I'm going to be raising x to the 2nd power, and I'm finding the 5th root of x to the 2nd power. So this is what we're looking at. Okay, this is what you should write down. We have rational exponent form and we have radical form. Here it kind of breaks it down. It says let a to the 1/n power. Okay, this is a fraction, so remember 1/n can be anything like 1/2, 1/3, okay, 1/7. Okay, be the nth root of a, and let m be a positive integer. Okay, so now it adds an m in down here, saying that, okay, if we were to multiply our fraction, because we have a power of a power here, and we had another number besides 1 in there, okay, we could write it like this. So a to the, let's say, 2/3 power would be written like this. Okay, if you broke it apart a little bit more, it could be written like this: a to the 1/3 raised to the 2nd. Okay, but then if we're going to write it in radical form, it would be written like this: the cubed root of a to the 2nd power. Okay, this has it outside of parentheses. Same concept, but so we could write it like this, but it will work the same way. Okay, so this is probably the best way to write it. So simplified, because this can get kind of confusing sometimes when they kind of write it all out. Okay, rational exponent form is a number raised to a fraction as a power or as an exponent. And then radical form, okay, we take that same thing, whatever's in the denominator is what our root is, and then we raise it to the power that's in the numerator. And really that's all we're looking for you to understand today. Okay, we're not going to simplify this. We could, right? The cubed root of 27 is what? 3. And then we could raise it to the 4th power. We're not even going to ask you to do that though, and that would be 81. We're just asking you to switch back and forth between the two. So even on your homework, it might ask you to simplify. All I want you to do is switch back and forth between rational exponent form to radical form and the other way around. So let's look at a few examples. It says write these in radical form. So A says 16 to the 3/4 power. Okay, so we're going to write it in radical form. We're going to take this 16 to the 4th power, all raised to the 3rd. And he explained to you what that would look like if you figured that out. You're looking for the number that would multiply by itself 4 times, would give you 16, and then you could raise it to the 3rd power. For B, we just did this one, but 27 to the 4/3. So we would say the cubed root of 27 raised to the 4th power. Okay, and we're going to go the other way as well, or if it's in radical form, we want to change it to rational. If it's in rational exponent form, we want to change it to radical. So if we look at this one, if we're changing this to a radical form, we would have negative 125, and all we have is the cubed root. So we know that that is represented, based on our con video, as 1/3. And we can keep that in parentheses. Negative 125 raised to the 1/3. Now, number 4, we have negative 64. Where my pen went. To the cubed root of negative 64 raised to the 2nd power. I'll try 5, you try 6. So we would have the square root of 9 raised to the 5th power. So go ahead and try 6. You're just writing it in radical form. Once you're done with that, you guys can get started on your homework. If you have questions, feel free to ask. But page 303, 3 through 6, 19 through 28, all I want you to do is rewrite the expressions. I don't want you to evaluate, because I know 23 through 28 says evaluate. I'm sure you could actually do that if you wanted to, but you don't have to. Have a great day.